good morning, and how are you doing? So, welcome to today's lesson. And in today's lesson, we're going to look at something different, but yet we're still going to cover the lipids because there are different types of lipids as we discussed in my introductory part of this um, lesson. So, in today's lesson, we're going to look at a type of a lipid that we call a triglyceride, or it is known as a triacylglycerol. Triacylglycerol. So, triacylglycerol. So, this is the name that comes as a result of combination of different um, substances or compounds. So today we're going to look at the triacylglycerol, or in simple terms, you can just say a triglyceride. So these triacylglycerol or triglycerides, they are simply types of lipids that are made up of that are made from an alcohol and also a combination of three fatty acids. So we are saying that these are lipids made from an alcohol, which we call a glycerol, and three fatty acids. So for you to have a triglyceride, we are saying triglyceride. So meaning you have three fatty acids, which is making it tri. Then you have one alcohol molecule, which we call a glycerol. So a glycerol is an alcohol which contains three alcohol functional groups in it. But we shall discuss more about this triglyceride structure when we look at its structure, the way it is drawn, and how it is made. So these are types of lipids, the ones that we are calling the triglycerides or triacylglycerides. They are just esters. An ester is a substance that is made from an alcohol or an alcohol and an acid. So when you react an acid and also with an alcohol, you get a product which we call an ester. So in simple terms, the other form or the other way in which we can define triglycerides, we can just say that they are esters of glycerol and three fatty acids. So that's the basic definition of this kind of lipid. So let's look at the functions of these kinds of lipids, the triacylglycerides or the triglycerides. So what are some of the functions of these types of molecules or these lipids? So number one, like I discussed in my previous video, I said the function of most lipids is that they store energy. And in the same manner, even these triacylglycerides or triglycerides, they also store huge quantities of energy. They are a huge storage of energy within the body. So they are storage sources of energy. Number two, they transport fat soluble vitamin, drugs, also cholesterol. So meaning, because of the nature of these kind of lipids, they are able to transport. There are two types of vitamins. There are vitamins that we call fat soluble vitamin and non-fat soluble vitamin, water soluble vitamin. But these kind of lipids, they are the ones that are able to transport because they allow some vitamin to dissolve into them. So they transport either the vitamins, they can also transport drugs, certain medication that we take. For them to be transported within the body, they need to dissolve through this media of fatty acids, which are of lipids, which we are calling the triacylglycerides. Then the third function, apart from transporting fat soluble vitamins, drugs, cholesterol, and other chemical substances, is that they emulsify food during digestion. So most of these lipids, like specifically the triglycerides, they emulsify the food that we eat during digestion. So they are very important because they help us to digest the foods that we take within the body. Then the other function of these triglycerides, apart from emulsifying food during digestion, is that most of these triglycerides, they are capable of providing insulation to the body. So they also act as insulators to the body, like we discussed in the previous lessons about these functions of lipids in general. So even those functions, they still apply to these triglycerides. Okay, so having discussed that, let us also look at the structure of these um, triglycerides. So the structure of triglycerides is very important that you know how to draw a triglyceride or a triacylglycerol. Okay, so how do you, hope you are able to see? Okay, so how do you draw a structure of this triacylglyceride? So that's a question of interest that you should take keen interest to understand how these structures come about. Okay, so the structures of these triglycerides are not hard. The first step that you have to understand is just know how to draw one reagent, which is a glycerol. So we are saying these kind of lipids, they are made from a glycerol and three fatty acids. In my previous video, I demonstrated how to draw a fatty acid. So if you know how to draw a fatty acid, then coming up with a triglyceride molecule is not shouldn't be a hard thing to do. But let's go through and see how we can draw that. So this is how a glycerol looks like. A glycerol contains three carbons. There is this one, that one. So you just write three carbons, then you join them by this bond. This. Then the hydrogen. You have the hydrogens this side. Then notice that each carbon should have four bonds. So there is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So having the understanding about that the carbon can only bond to 4 helps you to avoid making certain mistakes when you are drawing these structures. So this is how a glycerol looks like. No wonder we're saying it's an alcohol, because it is a trialcohol in short, meaning it contains this. Whenever you see the OH, this group, the OH, the OH is what determines or makes a substance to be called an alcohol. So this molecule, take note of how it is, then try to practice through draw this molecule. Pause the video and then try to practice this. Then what you notice is that it has um, these three alcohols. So this is how a glycerol looks like. Now, this glycerol will react with three fatty acids. Why? Because we have three hydroxide groups. So each fatty acid will bond with one fatty acid. For instance, let's look at this one. We are having this as the O molecule. Then it will react with a fatty acid. This is a fatty acid. This is a fatty acid. Then what will happen is that this OH will combine with this hydrogen, then this O molecule will join together. So this part and that will combine to produce water. Then, in case you've forgotten how to draw a fatty acid, this is how you draw it. You just write the hydrogen, then you write your oxygen, then it is attached to a carbon. This carbon should have a double bond, then you put the oxygen on top of it. Then this side, instead of writing these carbons, you can just use a skeletal form of writing. You do like this, meaning these, when you do like this, you are just showing that they are carbon or hydrophobic tails, which are made up of carbon. So this is a fatty acid. So another fatty acid will combine this group and the hydrogen will be eliminated. Then let's draw another fatty acid for convenience sake. Excuse me. So we have the hydrogen bonding to this part. Then we have C. Then we have that. Then we write the hydrophobic tails. Just do like that. You can write as many as possible. Yeah, now because of my space. So that's it. So now I have all the three fatty acids. So these are fatty acids this side. Fatty acids. So these can be of the same fatty acid. You can have let's say palmitoleic acid, lauric acid. You can have the fatty acid can be of the same or they can be different, but the product will still be called a triglyceride. So you have three fatty acids, this fatty acid, this fatty acid, this fatty acid. Each of these will combine with this hydroxide group. So there will be a reaction that will take place. And then they will form an ester linkage. So what will happen is now, when we draw the product, this is what will happen. This part, you just write the first step, you write the three carbons in a straight line and join them. Then this side, you just put the hydrogen, then on top you put hydrogen, this side, then you put hydrogen, and down there you also put hydrogen. Okay, then when you do that, the next thing that you do now, after doing that, is you now add, since this, the OH and the H, they have been eliminated, so you're just remaining with this H. So you just put the O, the oxygen, then it is attached to the carbon of the fatty acids, where you have this attached to a double bond, the oxygen, then your hydrophobic cells. It can be many or few. Then the next one, oxygen, then attach it to this one, attach it, follow my space, make sure that they are evenly spaced. Okay, double bonds, then your oxygen, yes, like that. Then you write your hydrophobic chains, like that. Then the last one, you also connect it, the O, then your carbon, then you say this is attached to the oxygen, then your hydrophobic, so this which we have here now is what we call a triglyceride. So this molecule, this is a carbon, and the molecule formed now is what we call a triglyceride or a triacylglycerols. So it is important that you know how to draw these structures. It will help you to come up with complex structures that you can come across in some complex lipids that we shall discuss. So this is the product now which we have is what we call a triacylglyceride. So this triacylglyceride, it was made from this glycerol plus different fatty acids. Then when they combine, they form a molecule which we call a triacylglyceride or an ester. An ester, how do you know that this is an ester? Whenever you see an oxygen attached to a carbon which is having another oxygen attached to it by a double bond, then this part is an ester linkage. So all you have to know is just follow through the steps and then try to duplicate everything that I just did as many times as possible. It will help you to get used and to know how exactly to draw this triglyceride. So that's it for today, and that's it on the triacylglycerides. Thank you so much for watching, and see you in my next lesson.